We were working on right triangles yesterday. Is that right? Do you guys remember? So what's going to happen now, I'm going to have you guys warm up here a bit. Kind of do the S portion in the beginning, because what we did yesterday was the S portion all day. So I'm going to say, what is X? They want the value of X here. So I'm going to do us a little bit of warm up on this. And oh my gosh, like always, it's a, there we go. So this is a bit different. They want you to find the value of X, okay? And I'll give you right triangles. (20 degrees), X, and 5, 2. (50 degrees), X, and 12, 3. Let's say 65 degrees, and this is X. So I'm going to find that value of X. Number 4 here. There we go. (75 degrees here. This measures 50. And then this is going to be over here 50 degrees. I'm going to say this whole thing is X. Okay, so we're going to get out our clock. Now the good news is we have, hopefully, what do we have? Hey, good morning there to Eric, and good morning to Adrian. I hope you guys are doing well. Good morning. Let's add a clock. I'm not that guy. Not that guy. We don't need that guy. Got to go back here. And delete that guy if I can. Okay. Delete him. Good morning. Don't know how that happened, but anyway, I'm looking for not a scene. Let's get our clock. I think there it is. There we go. All right, ladies and gentlemen, let's go over a few of these here. Now, what I want you guys to understand is this. The angle, here's kind of where you start, right? You want to start with these angles here. And again, all of these triangles, what are they? They're right triangles. Is that true? So how do you know they're right triangles? That corner there, 90-degree angle. Is that right? So again, this is kind of the S portion. You know, you say, Mr. Judge, what's the S portion? That review of really geometry. What side is X now over here on? Do you guys know? So over here in every question, they want you to find the value of X, meaning the length. This is the hypotenuse here, right? These are the lengths here. So what do you think you do? What do you guys think? Anybody have an idea? You want to use your trig ratio. So remember, in order to use a trig ratio, you have to have some language. In other words, for question 1, this is the opposite side. Is that true? And then this is the hypotenuse. So you're using the information they have here. What side for number 2 did they give you here for your right triangle? What side is this one here now? Do you guys know? What is this one? Well, the X is what side in relation to the angle? And then this is what was given too. The hypotenuse was given. Okay. All right, what about this one? What is this? What was given here? Ooh, nothing's given. Nobody asked. So I'm gonna give something here. Oh, okay, I'm gonna call this value what? Maybe 8. So okay. So what was given here? Now you say, okay, this is again the opposite side was given, and then I have to find this hypotenuse. All right. Nobody asked that one. Okay. And we'll leave number 4 out to later. But here's what I want to remark about this one here. You need the trig ratio that has the language of opposite and hypotenuse for number 1. Okay? So for number 1 here, what language, which trig ratio has the language of opposite and hypotenuse? Sine or cosine? Sine of this angle 20 degrees is opposite, which is X, over my hypotenuse, which is what? 5. Opposite over hypotenuse. Is that true for number 1? Now let's compare and contrast for number 2. Number 2, which trig ratio has the following? Adjacent and hypotenuse. Cosine, good. So number 2, I will say this. Cosine of 50 degrees is adjacent over the what? Hypotenuse. There we go, X over 12. Now, what about the next one here for number 3 here? Which one is that? You guys know? Yeah, for number 3, is that sine again? Which has opposite over hypotenuse? Sine 65 degrees is going to give you what? 8 over X. Is that right? So I want you guys to understand that detail. That's an important detail. So I'm going to leave out number 4 for now, but we'll get back to that. So what we're going to do now is this. You guys remember here, how do you get the value of X now? Because in every question, they want you to find the value of X. Anybody know? What do you do for the first one here? Multiply both sides by 5. What does that give you? X is 5 what? Sine tangent degrees. What about this one? Multiply both sides by now what? 12. So that'd be cosine of what? 50 degrees. Now, what about this one here? If you multiply both sides by x, I'm going to say this. It's going to be a little bit more sophisticated. Do you guys remember, what does this actually mean if I do this? It's cross multiplication because what you have here, again, is a what here? It's a proportion. A over B is C over D, and you can cross multiply. Okay? So here's a little bit of the algebra. So what that gives you here is x sine 65 degrees will be 8 times 1, I guess, which is 8. Is that right? So how do you guys solve for x in this case, for number 3? You divide both sides by what? Sine 65. So it cancels here, and so for number 3, x is just going to be 8 divided by what? Sine 65 degrees. All right, easy peasy lemon squeezy. So we're using the trig ratios to find all of these values of x. So the rest is going to be calculator work. All right, you guys okay with that? All right, so let's get out our calculators here for number 1. Number 2, I'm going to clear out what we already had. We're going to go to the Calc 84 again. Okay. So the first one, make sure, what mode does this have to be in to answer these questions? All right, so I have to change this from radians to what? Degrees. And it's in degree now. I changed it. So we're going to have 5 now, sine 20. We're going to close that. And ladies and gentlemen, what do we get? Let's go out to the tenths. X is 1.7. That's the distance, 1.7. Okay. Put the iPad there. 1.7 we got when we use our calculator here for 5 sine 20 degrees. What do you think we get here when we put 12 cosine 50? Let's see. Let's scroll out. Okay. We're going to put 12. And I guess I got to clear that. 12 here, cosine now of 50 degrees. What do you guys get now? What is x approximately? 7.7. Is that right? There you go. So you have 1.7, you got 7.7. Those are the distance for number 1, number 2 here. So if you said to me, well, you know, how do we do the next one? Remember, you have to take 8 now. You have to divide by sine 65 degrees. So 8 sine 65. So if I go to my calculator, okay, 8 divided by now sine 65 degrees. Close that up. What do you get as an answer to the nearest tenths? Right? What do we get here for 8 divided by sine 65? Isn't that 8.8? So in the iPad, this is approximately 8.8. All right, now we're going to get to the next one again, but I'm going to look at number 3 here just to give you some quick variations for number 3. Okay, because this can come up for number 3. I'm going to call this, it's not going to be number 3 here, but we're going to just say these are some notes, some variations here. And I'm going to change this on you. Because what they can do is they can give you this now. This is one variation. Okay. And then of course, here's another variation. They give you this. And again, we're trying to find the value of x for these particular variations. So notice again, they gave you over here, this is going to be the opposite side. Is that right? And then another variation of this theme. And let's change this on you. Variations, x, and then maybe they'll give you 25. And I want to point out now that with these variations, we got to identify what we're trying to find. Now, down here, isn't this, if we have to put an angle now, we'll say we got the angles there. Oh, maybe 38 degrees, 46 degrees, 22 degrees. We need an angle. Okay. Down here, this is the adjacent side next to the angle. Okay. So these are all variations here. So I don't know. Let's call that number 5 because we're going to get back to 4. Maybe number 6 and maybe number 7 here. So let's see if you guys can identify again here for number 5. What did they give you now again? You already know you have the hypotenuse, but what does that 15 represent? What side is that? Good. The adjacent side. What side did they give you? Up. You already said that's adjacent. Good. And we already said that's adjacent, but what is the 25? Opposite side. Okay, it looks like we labeled everything. All right, well, looks like we're good to go. Is that right? So for number 5 now, you're going to have to give me a trig ratio. What's the trig ratio for number 5 here? You got to know adjacent and hypotenuse. What trig ratio is adjacent and hypotenuse? Cosine of 38 degrees is going to be what? Adjacent. What's the adjacent side? 15 over that what? Hypotenuse. Is that right? You guys okay with that for number 5? Okay. Number 6, which trig ratio has opposite? Yes.
So for number 5, why exactly do we use cosine? Why not sin?
Why not sine? Well, what's the definition of sine? Let's put that there. What is sine theta by definition? Opposite over what? Hypotenuse. So the question is, why not use sine? Because you don't have the value of the opposite side. So in all honesty, what you're using is those geometry definitions we went over, but maybe to emphasize, let's get out the green. You have what? 15. Oh, not the green marker. You have here's the highlighter. You got this 15 and you got the x. Okay, over here you got the 15 and you have the x. So for number 6, yes, number 6 we can say sine 46 degrees because the information that they're asking for number 6 involves the what? Opposite. Oops. I don't use sign for number 6, do I? What do I use? Uh-oh. Which trig ratio involves language of opposite and adjacent? So that one has to be tangent. Is that right? Okay, you guys okay with that? So this has to be tangent, and that's going to be x over what? 15. So the ratios here are being used. So that's for number 6. What about number 7, ladies and gentlemen? Which ratio involves language of opposite and adjacent? Which one? Is it tangent again? Okay, so what do we say? Tangent of what? 22 degrees becomes, what is this? 25 over x. Easy peasy lemon squeezy. I'm looking for, okay. All right. So what I'm going to do now is this, remind you guys, all of these variations, like for number 5 over here, how do we actually handle that? Yeah, I mean, you can multiply both sides by x, but I'm going to do a little transition here for a good reason here, okay? I'm going to turn this again into, what do we call that again? A proportion, okay? So I'm doing that for good reason, but you're right. You can multiply both sides by x. That's really the same thing. You say, Mr. Judge, what are you doing? We're going to transition to what's called law of sines, and then you're going to see that. So you're going to see this again. You say, okay, AD equals what? BC. So at this point here, you get now what? X cosine 38 degrees is 1 times 15. Is that true? So this is actually the same exact thing you said, that you'd get the same answer, is what I'm saying. So what would you guys do now here? Remember, this is still geometry. This is still the S. We've been working on the S portion. Divide both sides now by what? Cosine 38 degrees. And you get x going to be equal to what? 15 over cosine 38 degrees. So I really want to go over this kind of detail because this is the kind of detail we're heading into. This is still the S portion. This is still really, ladies and gentlemen, the supplementary because it's geometry. And so at this point, we're going to use our calculator to get the x value. So you guys okay with this? Everybody remember what I'm saying? So 15 divided by cosine 38 degrees, we go to the calculator. $15 divided by what? Cosine 38 degrees. What do you end up with? What is this approximately? 19.0. So this again is the complete process. You guys want to do that here. What about number 6, ladies and gentlemen? We already set up the equation here. I'm going to go with the proportion idea, but you want to know something? We don't have to on this one. I mean, you can. Let's do that. Work with this proportion again. To equal fractions is a proportion. So if I cross multiply, remember, what does that give you now? 15 times what? tangent 46 degrees becomes what? X. Okay, you guys okay with this one? Easy peasy lemon squeezy. You say, isn't that the same as just multiplying both sides by 15? It is. But I'm going to put my x on the left now. What do you guys get if we put x on the left here? Where do you go here? Calculate here. So, ladies and gentlemen, here's what we're going to get now. 15 tangent 46, and that's going to equal, what is this? To the nearest tenths. Is that 1.6? There we go. What did I do? Did I do something wrong? Let's see. Oh, 6. Sorry about that. Let's change that. Clear. It's 15 tangent 46. Okay, it looks like we didn't hit the 4 quite right. 15 point what? 5. Number 7. Divide this by what number? 1. Cross cancel. What do you end up getting? X times tangent 22 degrees is 1 times 25. Is that right? So that now means x tangent 22 degrees becomes 25. So when you divide now both sides by tangent of 22 degrees, right? You end up with what? X going to be 25 over tangent of what? 22 degrees. So 25 divided by tangent 22 degrees. If we go to our calculator now, what do you guys get? What do you guys get approximated to the tenths? Is that 61.9? You guys get that there, 61.9. So here we go. This is going to be 61.9, ladies and gentlemen. Easy peasy lemon squeezy. Now, the last one, the one we skipped in the warm-up here, this is kicking things up, just so you guys know. Okay? Now, we're going to actually transition, but I want to go through some algebra here, okay? What do you guys know about this big triangle here for number 4? Let me get it in gray. Number 4, what do you guys know about this? Is this a right triangle? What do you guys say? Is this a right triangle? I'm going to put right triangle, and that's a question. What do you guys think? Yeah, but I'm asking for the gray. The answer then is just simply a what? No. Huh? Okay, you guys, the point I want to make is you don't have a right triangle. Now, the reason I'm making that point is we're going to transition to, I would say, a topic where you get to solve triangles, but they're not right triangles anymore. That's trig. This is still geometry. This is still S supplement. Okay, you guys see what I'm saying? So then you go, okay, well, how do we do that then? So I just want you guys to see that so you can appreciate what comes next. Because, yes, you could do some of these questions this way, but what comes next, I want you guys to appreciate. Okay, you guys know what I'm saying? Okay, so here we go. Now, did anybody get a value of x? What is your approach? Anybody have a nice approach from geometry? What's the geometry approach? If this is a right triangle, this is another right triangle. Is that right? So here's the geometry approach. Yes, there's one right triangle, and then here is the, oh, stay there, stay there. So here's the other right triangle. You guys with me on that? The base of this big triangle that was in gray is x, and we want to find that. But using that technique, here's what I'm going to say. Separate the two triangles here. I don't know if you guys did that. Did anybody do this? You guys know what I'm talking about? Did you separate the two? Yes, exactly. First right triangle, second right triangle, 75 degrees. This side measures 50. In fact, I'm going to keep it next to it. This is 50 degrees too. So if you guys can see this, hopefully, I didn't do anything really but separate my triangles. Now, what sides are over here? This is going to be what? A, and what's this? B. Okay, so far so good. So why did I do this, ladies and gentlemen? Do you guys know? Because I need to find these two values, A and B, down here, this length and this length. Why do I need the lengths A and B? Because if I add them, that's what X is. So what I'm saying to you guys is that distance X is A plus B. So if I can find A, if I can find B, then I definitely know what that is. All righty. So how do we get A, ladies and gentlemen? How do you guys get this one here? What is this again? Opposite over what? Adjacent. Is that right? So we know tangent 75 degrees is 50 over A. This is going to be how we get A now, ladies and gentlemen. Okay? We also know, what else? Tangent 50 degrees is opposite 50 over the adjacent B. So this is how we get the next one, B. So far, so good? All the stuff that we've been doing. Now, use that algebra over 1 over 1 Use the algebra, cross multiply if you like, okay? Now, what you'll end up getting is the following. A tangent 75 degrees is 50, which means A will be 50 over tangent 75. Over here, we have B tangent 50 degrees equals the number 50. And again, cross multiply. Oh, no, we did cross. Divide by what? Tangent 50. You get B equals 50 over what? Tangent 50. What is A? What is B? 50 tangent 75, ladies and gentlemen. What do we do? Here it is. We're going to get what? Let's try this out. 50 divided by what? Tangent 75. Oops. Okay. What is this going to be? 13 point what? Is that 13.4? All right. What's the next one? Isn't that 50 divided by tangent of 50? Is that right? And that one's going to be what? Yeah, it's going to be about 42. Okay, 42.0. Good, good. So double check that we did everything okay, right? Because remember, we need to take this A value and the B value. What do you do with A and B? You add them. So you say, oh, is that going to give me my X? Yes. So what is 42? What is 13.4 plus 42? I think that's 55.4. Is that true? Okay, so X is going to be 13.4 plus 42, and you guys say that X is now going to be 50 what? 55.4. There you go. And that's your distance, 55 point what? 4 down here. Now, we're going to transition from right triangles to non-right triangles. So this is the S portion. This is geometry. So you say, well, how do you transition from those courses? Well, let me share with you